Thank you. Good afternoon, everyone. Welcome to Simple Infrastructures That Simply Scale, and that is the first time I pronounced that properly since rehearsing this. I'm currently the Director of Web Operations at a company called Spring. We're located right here in New York, over Madison Square Park. Spring is a fashion e-commerce marketplace. We've been around for about 4 years, or initially starting with an iOS app, and in the last 2 to 3 weeks, we actually recently launched a personalization effort. So we want to make shopping a personalized experience for you, based on your favorite brands, based on the products you like, your own personal style. We'll give you recommendations based on that. And of course, we are hosted on AWS. So let's take a trip back in time 10 years ago. AWS had 3 offerings available. We had EC2, which was our server infrastructure, which at the time had, I believe, 1 instance type. And this is right around the time I actually started using AWS myself. You had no AWS console. You had some Java CLI tools, I believe some Ruby scripts that were used to manage the API. You had SQS, which was our queuing system. And you had S3, which was our object store. And you had companies beginning to migrate to AWS when there was only 3 services available there. You had companies with hundreds of thousands of users. You had companies with millions of users. And they were still scaling and continuing to deal with their traffic with just these 3 choices available to them. Fast forward to today at the summit, we have hundreds of AWS services available to us. We've got any service that you can think of that you were probably managing on your own, Amazon has a managed solution for now, right? We have RDS, we have Firehose, we have, you name it, more are being launched today, more are being launched each month, and so on. So now we have all these choices on different services we can use, which leads to different ways we can solve a problem, which, having a ton of choices doesn't always mean that's a good thing, and we'll see why that is shortly. So let's jump back in time a little bit for Spring itself, and let's look at what Spring's infrastructure looked like about a year and a half ago. So about a year and a half ago, our infrastructure was using these main services for hosting our APIs and our services. So we had some stuff on AWS OpsWorks, we had some stuff on Elastic Beanstalk, we had some infrastructure that had begun migrating to Docker ECS-based solution, and we had some servers that were in EC2. Some of it was being managed via Ansible, some of it was not being managed via Ansible. Some of it was just had no config management, which wasn't so great, but we had services spread across 4 different ways of doing things. So what did this mean? We had 4 different ways of deploying code. If I had to update a secret that was being used in all these services, then 4 different places to do it. And if an on-call engineer got paged, they had to sit there and go, wait, which service is this infrastructure being hosted on right now, and find where that was. So one of the things I've learned in my short 10-year career is being consistently wrong is better than being inconsistently right. And you notice that you have wrong and right both in quotes here, because neither one of those mean, you're right or wrong in that sense. Was the solution of going with OpsWorks wrong? No, it works perfectly fine. Was ECS wrong? No, all those solutions worked fine in their own, but because we had 4 different ways of doing things, it led to a lot of confusion. So when we sat down at Spring and we looked at how can we simplify this and make this better, here's what our infrastructure breakdown kind of looked like. So we had about 30% of our infrastructure is around APIs. Around 40% of our infrastructure was workers. And then I threw everything in this other bucket, which I know I kind of greatly oversimplified. But the other bucket just means ops infrastructure. So it's things like our Jenkins server, our Puppet infrastructure, our Elasticsearch servers, our logging infrastructure, and so on and so forth. But really, when we kind of roll this up a little further, we can kind of say 67% of our infrastructure is engineer managed. So they're the ones making changes, launching new things, and affecting these part of our infrastructure on a daily basis. So when looking at a way to come up with a simplified solution, we need to make sure that our engineers were able to simply manage this without having to deal with any confusion or anything that could possibly go wrong. So one of the goals of that was it was going to be simple to launch new services. And our AWS experience on our engineers ranges from people who just graduated college who haven't really used AWS yet, to people with 7 years experience, to people with experience in a really deep dive on certain services, which is great. But no one's expected to be an ops engineer. Nor, if they want to learn more about it, I'm happy to sit down with them and tackle it together. There's so many services that I don't even know the names of everything anymore. Like they're better suited than I am these days to learn about this stuff. And one of the other goals too we had was we wanted to minimize surprises on change. And I'll talk about that more in a second, what that actually means. So really, when we took a look at things, there was just 2 things that it came down to. Is we need a template for worker services and API services. API being things that took in requests, workers being things that just processed some stuff, put it into a database, and read off the queue, and so on. So what we ended up with in our current infrastructure is a CloudFormation-based solution. So we went with the infrastructure as code solution that a lot of people are going with. And really what every CloudFormation template has is it's managing an auto-scaling group. So even if it was just one server, that one server was in an auto-scaling group. So if that server died, it automatically would come back up and healed and everything. So worst comes to worst, you don't know what's going on with the server, you can just kill it off. It should come back up cleanly, hopefully. And if it doesn't, well, we're in some trouble. Each one of these services has an IAM profile, so we're not using AWS access keys or secret keys. We're just using IAM profiles. Everything's happening seamlessly. Each service gets their own security group, so we're making explicit security port openings per each service and not just opening up things to the world when it's unnecessary. ELB was optional. You know, if it's an API, it's going to get a ELB in front of it. If it's a worker, it doesn't need an ELB. And then Puppet took us home and bootstrapped the rest of the server. At the very end of it, we have a simple code deploy. We're not actually using AWS code deploy. Don't confuse those two. Where we just have a simple script that just pulls a build artifact off S3 and puts it in place and restarts the supervisor process. So really, this is it. We actually made two exclusions to the infrastructure as code, where we didn't include RDS on purpose, and we didn't include Route 53. And the reason for that is twofold. RDS, most of our infrastructure is pretty much built already. We're not launching RDS services or databases on a monthly basis. And also, there's a few changes you can make in CloudFormation with RDS, where you could potentially restart your server if you're not familiar with the change you're making, or potentially bring up a whole new resource. And I know there's some options you could set to prevent that, but going back to one of our original rules of minimize surprises, no surprises. And the other thing was we left out Route 53 in most of our CloudFormation templates. We did make exceptions to a couple. And the reason for that is if someone's coming along and they want to bring up a parallel infrastructure to test something out, if that person just copies that CloudFormation template and it's modifying a Route 53 entry, and that Route 53 entry is not a unique name, they could potentially bring up a new service, put it into production without realizing it. So again, minimizing surprises. The end of bringing up a new service is you're just going to update a Route 53 record, and you're going to say, okay, this is live now. And if you want to bring up a parallel infrastructure that you're going to cut over to, you're just making that DNS change, so you don't have to worry about affecting anything. So taking a look a little further into what our setup looks like, we really just have two main operations we're doing. We're creating new stacks, and we're updating existing stacks. And these are literally our script names: update stack.sh, create stack.sh. These are just wrappers for the AWS CLI tools. And they take two parameters. They take an environment. So we have three environments. We have a dev, demo, and production environment. And we have a template that we're going to specify. And if you take a look at, this is one of the examples from one of our production parameter files. The thing that really differentiates between the dev, demo, and production parameters are just the number of servers in an auto-scaling group, the instance size, the Puppet role. What else do we have? Whether it's going to be in a private or public subnet, whether it's open up to the world or not. And for some of our API workers, some ELBs have some additional parameters that we change. So that's really it. So really when an engineer comes along and they want to bring up a new service, we have some templates in place that are API template and worker template. They're just copying that, renaming it, and they're just setting the parameters of what they should, they're using their best guess of what their instance type should be, how many servers should be in the auto-scaling group, and so on. If you notice, there's purposely no delete stack.sh. So again, going back to minimizing surprises, making it simple. We took the decision that we're not going to delete stacks ever. Not that we never do when we're deprecating infrastructure or doing anything else, or when we're bringing up new infrastructure. Sometimes if you're fooling around with new CloudFormation syntax, you might get into some weird state and you have to delete it. But we really want to make it a thought process that if you're deleting a stack, you really have to think about it and understand why you're doing it. So there's no script to make it an easy process to do. So one of the other approaches we take at Spring is kind of like this approach of, do you want to use a new technology or do you need to use a new technology? We have so many choices available to us on the AWS infrastructure. I could build a simple WordPress blog and I could probably use 50 plus AWS services if I wanted to. I've actually been meaning to write a blog post. I want to build like a Rube Goldberg style machine and see how many AWS services I can use for just hosting a simple website and see how many I can hit. And I don't think I can hit all of them because there's just so many available to us now. So I think what a lot of questions start coming up when you introduce a new technology. And what I mean by new technology, I mean a programming language, a queue system, a database, and so on and so forth. To give you an example, about a year ago, we had a service that we just had to have a simple external-facing webhook service. Sound pretty simple. It just needed to take some data in from a vendor, do some processing with it, and just put it elsewhere. Someone said, hey, this seems like a perfect use case for Lambda, which I was like, yeah, this seems like a drop, shoe-in for Lambda. Lambda was kind of newish at the time. So when we started diving into it, we're like, all right, let's see what it offers. So we're a Python and Go shop. Our Python infrastructure is on Python 3.5. We looked at Lambda. Lambda at the time was on Python 2.7. It's like, okay, well, our deploy process, we manage our deploys using Jenkins. We have Fabric under the hood managing our deploy process. All right, how would we fit this into our deploy process? Lambda at the time really didn't have any workflows. How do you develop it locally? How do you test it locally? Our log infrastructure is all elk-based, so Elasticsearch, Logstash, Kibana. The Lambda logs go into CloudWatch logs. How are we going to get those logs into our existing infrastructure? Our monitoring is done via Datadog, and our alerting is done via Datadog that's hooked into PagerDuty. Can we get those metrics in place? Can we alert on them? So we start diving into all this stuff where it's like, oh, here's a simple solution with Lambda. Actually, really, we had to do a lot more work if we really want to use this solution. And then if we even did that, and it would have costed us literally pennies a month probably to run, but if we would have went with this solution, if someone got paid for that service or had to troubleshoot that, this is a one-off that's unique to everything else that's completely different than how we do things. And it really just wasn't worth the cost of saving a few dollars a month where we had this existing infrastructure in place. So I think you tend to, when you introduce a new technology, kind of have to run through a lot of these questions. How do we scale this? Has anyone even used this before? I've been using some technologies for 10 years now, and I still am surprised how it fails at scale in different ways. And it's just one of those things that I think you have to take a second and take a step back before you jump into something new. So let's take a look at these two infrastructures right here on the left and right. You have your classic 3-tier architecture on the left from the AWS examples. Both of them do the same thing. They're just a simple web hosting site. Simple, depending on your definition of simple. Which one of these do you think is easier to operate? Is it on the left or the right? Which one of these do you think requires less domain knowledge? Which requires, if you get paged in the middle of the night, which one has the scenario where more things can go wrong? We're using 3 different database technologies on the right here. We've got Postgres going on, we've got MySQL, we've got Redshift, we've got some services in ECS, we've got some stuff in Elastic Beanstalk. All these services are great. Each one of these architectures can scale to whatever needs you may require, but one of these requires a lot more knowledge, one of these requires a lot more things that could go wrong with it. So, excuse me, I'll wrap up this talk with this quote from a German architect, which I will probably butcher this name, even though I was watching YouTube videos on how to pronounce his name. Ludwig Mies van der Rohe, who is a German architect and product designer, furniture designer, whose mantra is less is more. So he says, that which is less complicated is often better understood and more appreciated than what is more complicated. And I think a lot of us can take this to heart when designing server infrastructures and architectures. And when we take a look at new technologies, really take a step back and see how we can actually integrate these into our work process, and rather trying to solve problems that we don't actually have yet. So, and that's it. Thank you very much.